Hello, hi everybody. Myself Ramesh. Especially today we will see that very basic topic especially in organic chemistry like amines. What is amines? What are the source of amines and the some amine based reactions we will discuss today. So you can see that before we are going to discuss and after the completion of amines, you will see the previous important bits practice bit also. Okay. So now we can see the first one slide. What is amines? Amines are organic derivative of ammonia with one or more alkyl and aryl groups bonded to the nitrogen atoms. An amine is an organic derivative of ammonia in which one or more of the hydrogen atom has been replaced by hydrocarbon groups. So amines are organic derivative of ammonia. Okay. With one or more alkyl or aryl groups bonded to the nitrogen atoms. An amines is an organic derivative of ammonia. So the simple you can see here, what is amine means? Amines are the organic derivatives. Simple you can say one word. Amines are the organic derivatives of ammonia. Here the ammonia, it consists of nitrogen atoms chemically bonded to 3 hydrogen atoms by a single covalent bonds. Nitrogen atom also has a lone pair of electrons. Nitrogen atom also has a lone pair of electrons. Amine serves many functions in living organisms such as bioregulation, neurotransmissions, and defense against predators. Because of their high degree of biological activity, many amines are used as drugs and medicines. The alkaloids are an important group of biological active amines. Suppose you can see here, mostly synthesized by plants to protect them from being eaten by insects or other animals. Although some alkaloids are used medicinally as painkillers, like all alkaloids are toxic but cause death when taken in the larger quantities. So whatever you can take it nowadays, the ADI means acceptable daily intakes. That particular range it will be crash our limits. It should be toxic to our body. Whatever anything. And the mild cases of alkaloid poisoning can produce psychological effects that resemble peacefulness, euphoria, and the hallucinations. This kind of happening when we do that large quantity of alkaloids. Now you can see the source of amines. In nature, amines occurs in proteins, vitamins, alkaloids, and hormones. Okay. The source of amines you can see in nature, amines occurs in protein, vitamins, alkaloids, and hormones. The synthetic example include some polymers, dyestuffs, and drugs. Structure of amines like ammonia, nitrogen atom of amines is trivalent and carries an unshaded pair of electrons. Nitrogen orbitals in amines are therefore sp3 hybridized and the geometry of amines is pyramidal. So for example, you can see trimethylamine. You can see that this methyl group, three methyl groups are bonded in nitrogen atom and one lone pair electron. Actually, that is the structure that of amines. Structure of amine. It is a sp3 hybridization. Now you can see here the classification of amines. So classification of amines also very important. Amines are classified as a primary, secondary, tertiary corresponding to 1, 2 or 3 alkyl and aryl groups bonded to nitrogen. Ammonia NH3, primary amines are NH3, secondary amines are 2NH and tertiary amine RN. These are the amines of classified primary, secondary, tertiary corresponding to the 1, 2, 3 alkyl and aryl groups bonded nitrogen. Then you can see quaternary ammonium salt have 4 alkyl or aryl bonds to a nitrogen atom. The nitrogen atom bears a positive charge, just as it does in simple ammonium salt such as ammonium chloride. Then CH3CH3 plus H minus. The quaternary ammonium salt are widely used not only as organic basis but also as a deep protecting agents, phase transformer, catalyst, surfactant and disinfectants, ionic liquids, ion pair reagents and more. These are the quaternary salts are widely used not only for organic basis. Okay, then you can see here common names, formula, a systematic IUPAC name, common name, type, CH3NH2, methyl, methaneamine, methylamine, primary, CH3CH2NH2, ethylamine, ethylamine, primary, CH3 twice NH, N-methyl, methaneamine, dimethylamine, secondary, CH3 twice N, N, dimethyl, methylamine, trimethylamine, tertiary, C6H5NH2, aniline, aniline and primary. And you can see this one, the N-phenylalanine, diphenylalanine and secondary types. Now you can see the explanation of few important amine reactions. You can see that few alkylation amines reacts is alkyl halides to add alkyl groups to the nitrogen atoms, potentially forming secondary or tertiary amines depending on the reaction conditions. Next, acrylation. The primary and secondary amines react with acid chloride or anhydrides to form amides. Benzoylation, the specific type of acylation using benzyl chloride to identify primary and secondary amines. Next one, Hofmann rearrangement reaction. You can see the use to distinguish between primary, secondary, tertiary amines by reacting with a sulfonyl chloride. So, Heisenberg reaction. Then you can see carbonyl amine reactions. This test is primary amines where they are react with chloroform or alcoholic potassium hydroxide to form few smelling isocyanate. Squatting-Bumann's reaction. The method to prepare amide by reacting an amine with an acryl chloride in the presence of aqueous sodium hydroxide. So these are the few explained about the amine reactions: alkylation, arylation, benzylation, Hofmann rearrangement reactions, Heisenberg reaction, carbonyl reactions, Squatten-Baumann reactions. Then you can see that some methylamine structure, trimethylamine, already you seen in structure. Then after ethylamine, aniline, dimethylamine, benzylamine. Then factor affecting on basicity. The following factors governance the basicity of aromatic amines: resonance effect, inductive effect, hydrogen bonding, orbital nature of electron pairs, steric effect, solvenation effect, electronegativity of bonded atoms. Then methods of preparation of aromatic amines. So you can see that some preparation of aromatic amines: reduction of nitriles. See, nitriles can be reduced by lithium aluminum hydride, LiAlH4 to primary amines. This is that benzene, ether, benzylamine. Reduction of nitro compounds. Aromatic amines are normally prepared by reduction of the corresponding aromatic nitro compounds. The nitrobenzene OH, aniline, and meta-nitroaniline and 3-methyl aniline, meta toluidine, NH3CH2. Reactions of aromatic amines. Formation of amide from acryl chloride. So addition of primary, secondary, the acids chloride results in formation of amide. Benzyl chloride, acid chloride. Then salt formation. The reaction of amines with acid will give amine salt. Then you can see aniline, NH2, 3 Br2, Br2/H2O, 2, 4, 6 tribromoaniline. Okay, 3 HBr. Then you can see practice bits. The amines can be considered as derivative of dash obtained by the replacement of hydrogen atom with alkyl and aryl groups. So already we discussed in the first slide, the amines are considered as the derivative of ammonia, NH3. So the right answer is ammonia is right answer. Second one is what is the most basic aromatic amines common name. So here is given option 4, benzenamine, benzylamine, aniline, aminobenzene. So aniline is the one of the most basic aromatic amine. So right answer is the aniline. Then third one is for which of the following is the Heisenberg approach used. So Heisenberg approach used for here giving the 4 options. One is the preparation of primary amines, separation of amine mixtures, and preparation of tertiary amines, and preparation of secondary amine. So the Heisenberg approach is used to separation of amine mixtures. The amine mixture is separated by using Heisenberg approach. Then fourth one, which of these substance has a lower melting point than amine. So which one substance have the lower melting point than amine? Means alcoholic, ether, carboxylic acid, or phosphine. Phosphine is the right answer to this is the lowest melting point of the amines. The fifth one you can see here, amides can be converted into amine by the reaction named after. You can see here the down they give the number of options, Perkin, Claisen, Hoffman, and the more than one of the above and none of the above. So what is that question? The amide convert into amine. That reaction is called Hoffman reaction. So Hoffman means nothing but of degradation of amines. So right answer is the Hoffman reaction is the amide is converted into amine. Then you can see the sixth one. Which of the following is the functional group of amine? So here is given oxygen, nitrogen, helium, barium. So which of the following is the functional group of amine? So you know what is amine? The amine is the one of the organic compound derivative of ammonia. In ammonia, it is having the nitrogen atom. So nitrogen is the one of the main atom of the amine. So which of the following functional group in amine is the right answer is nitrogen. So here is the right answer is the B. B1 is the nitrogen. Okay. So like that these beads will be next class we will discuss more about that competitive exams like MSET and NEET exams, and you can see some practical exams and theory exams we will discuss in about amines, what is amines, and number of question types and multiple choice questions in NEET exam and MSET engineering medical kind of. So if you like this video, please subscribe, like, share and comment. And next video in the next class we will go in detail about the what is amines, amine based important bits, multiple choice question bits, and amine based statement bits. These kind of bits, important bits, and some important questions of amines and important reactions of amines we will discuss in next class. Thank you for your kind attention. Like, share, comment. Bye.